Assalamu alaikum, Honorable Judges, Technical Chair, and the organizer of TENSIM 2020. Here is our presentation title Android App-Based Bluetooth Control Low-Cost Cloth Folding Machine. I am the first author, MD Shahnawaz Ehsan, and here is my co-authors Shaun Dash and Hossein Mobarok. We are from Department of Electrical and Electronic Engineering, Premier University, Chittagong. Here is our contents: introduction, literature review, methodology, 3D CAD design, block diagram, schematic diagram, flowchart, controlling apps, results comparison, and the conclusion. Introduction. Our paper describes an electromechanical device that can fold various types of cloth like shirt, pant, towel, sweats, etc. The most common problem in our daily life is after washing and drying the clothes, people simply dump their clothes into the storeroom without arranging properly. To get rid of this problem, we are presenting an easy and economical solution, and it is the cloth folding machine. In our system, actuators control the motion of folding. The angle of rotation controlled through the program of microcontroller, commanded and apps, which is designed in MIT App Inventor. It is predicted that by utilizing this machine, cloth folding time can be reduced to a great extent compared to the other traditional methods, and our system is most economical than others. Literature review. In the first reference, a learning method of cloth folding manipulation by dual arm robot has been proposed utilizing the physics simulator. They used a simulation for the shirt, pant, and various cloths. And in the second reference, a cloth model with mesh structure has been proposed, and the folding procedure is shown by cloth model fitting. And they generally make a simulation, and this simulation shows us the ratio of different cloths and different technique and of folding. In the third reference, folding behavior execution of a shirt by dual arm robot has been described. Then in the fourth reference, by using photosensor to detect the presence of cloth, a cloth folding machine has been developed which can fold the cloths automatically. They used a photosensor to detect the cloths. Um, and comparing to ours, we generally make it simple and efficient. That's why which is controlled through the Android apps. In the fifth reference, learning from demonstration technique has been proposed for a robot which has human physically guides a robot to perform their task. The robot generally learns from the human how people fold their clothes, and as a learning method, the robot can perform the task automatically. In the sixth reference, a photovoltaic cloth folding system has been introduced, where the system is operated through the DC motor fitted with some mechanical fitting accessories. And comparing with our system, this photovoltaic system is not economical because of the DC motor, and where we use the servo motors, which has a closed loop system and angle rotation system. In the seventh reference, dividing three steps, the authors divided their system in three steps: isolation, unfurling, and folding mechanism or cloth plication has been proposed. And in the last reference, an automatic t-shirt folding device has been proposed and designed through a PIC IC. And we generally designed our system with Atmega 328 IC. Methodology, and first of all, the 3D CAD design. We designed this system in SolidWorks, and this system shows that there are various steps of folding: 1, 2, 3, 4, and 5. These are the steps of folding behavior, and the last one is the roller, which fold the long cloths. This is our system block diagram. In our block diagram, this is the power supply unit. This is the power supply unit, this is the mechanical unit, this is the control unit, and this is the user interface, and this is the switching unit. In the power supply unit, we used a 12 volt 5 ampere adapter and a buck converter for regulating power supply. uh, to the control unit and the motors. In the mechanical unit, we used a servo motor, and we used about 4 servo motor and a gear motor. The servo motors have the closed loop feedback system and controlled through the Atmega 328 IC, and the gear motor controlled through the switching relay, and the control signal comes from the Atmega 328 processor. So, user interface system is designed as an Android app, which is designed in the MIT App Inventor, and the Bluetooth communication comes from the user interface. Also, the manual control unit has been developed with the system circuit diagram where the power supply comes from a 12 volt regulated power supply. This is the buck converter which regulates the power supply to into 5 volt from 12 volt input. This is the our Arduino Atmega 328 base platform. There are 4 servo motors digital pin with connected with digital pin 8, 9, 10 and 11, and this is the relay signal comes from the digital pin 2, and relay control this gear motor. And this is the Bluetooth HC05. Bluetooth HC05 is connected with the receiver from Arduino. Our flowchart of the system. When the program starts, the initialize the Bluetooth communication, and after initializing, the program calls if there is any app data available from any Bluetooth device. If the Bluetooth signal comes from the shard, the servo 1 goes to the forward and servo 1 goes to the reverse. Then the step 2, servo 2 goes to the forward and servo 2 goes to the reverse. Then the step 3, servo 3 goes to forward and servo 3 goes to reverse. And next, the last step, servo 4 goes to forward and servo 4 goes to reverse. We tune this servo in various angles, precise folding. And when comes the signal as a band folding, the servo 1 goes to the forward, servo 1 goes to the reverse. Then the next step, servo 2 goes to forward and servo 2 goes to the reverse. And when the signal comes from an Android app, that we need to fold a long cloth. We have to attach the long cloth with the roller, and after pressing this button, the signal comes from the Bluetooth. The gear motor will go to the forward, and after a while, 5 seconds to 10 seconds, the long cloth will be folded. This is our controlling app designed in MIT App Inventor. These are the buttons. This is the shirt. This is for shirt. This is for pant, and this is for long cloths. And this button is for controlling the roller movement or various timing. This is one kind of a push button. When we push this button, the roller will goes through the forward, and when we release this, the motor will stop automatically. At first, we need to connecting the device with Bluetooth. For connecting the Bluetooth, we need to press the Bluetooth icon, and this will be connected with the apps. This is our cost estimation. We used a Arduino, a Ford MG995 servo, a gear motor, a relay module, a Bluetooth module, a breadboard, some wires, a power supply, and a buck converter. And others are $4. All the costings is about 45 US dollar, which is about 4,000 Bangladeshi taka, and this is so efficient and low cost device for our country. This is our implemented device, and these are the result. First step, second step, third step, fourth step, and fifth step. The steps are shown. I will try to show a video at last of this presentation. Here this is a simple comparison with other existing methods. First one is the traditional folding method, which is folding through the raw hands, and the second one is a machine FX23 cloth folding machine, which is used in various manufacturing company and the various garments. This is completely a industrial product and is not for household use, and this is comparatively so high cost. And the third one is Foldimate. Recently, this Foldimate company launches their product and they are getting pre-orders option, which is about 2000 US dollars, which is also so high for ours. And the fourth one is a board folding method. Board folding is comparatively low cost, but in this method we need to use hand again, and this is also not inconvenience. And the fifth one is our system cloth folding machine. We use some motors with existing board fitting method and also attach a rolling method for long cloth folding. And we also design an Android app, and this is the conclusion. Our cloth folding machine was designed and implemented for folding various types of cloth through the Android app command. The whole software system was implemented in Arduino platform. The system can assist and provide support to fulfill the needs of everyone like family and cloth shop, laundry to fold their existing cloth easily. We have some future works to development, computer vision technology and the automatic cloth detecting technique can add it. Also, the cloth storing and sorting various types of cloth will be the great extraction of this work. Here is our references used in our paper. Thank you all.